Hello and welcome. Today's demo video is about our UTM or next generation firewall, which is Kerio Control. Today we're basically just going to go through the product and basically explain some of the capabilities of the solution and how you can use it to protect your company or organization networks going forward. So I'm just logging into our administration portal or user interface. And the first screen that you get to is effectively the Kerio Control dashboard. Obviously from here there's a few things that you can see. Most of it is an overview of your entire environment, such as resource utilization on your server, system details, whether or not all of your modules are correctly configured and working correctly, some throughput details regarding your internet connection, specific hosts or users, whether or not any users are currently connected to the VPN, obviously WAN and other Ethernet or other network interface traffic graphs, and then of course a little new section in the event that there are any major updates released from Kerio. Next, what I want to show you is the interfaces section, and this is just to explain exactly how easy it is to implement Kerio in a particular network. And the main reason for that is the way that they group various items within the system in order for you to use those items as a logical identifier. So one of those examples is the internet interfaces. So if you, for example, had many different interfaces underneath here, you'd be able to set them up not only as a single internet link, which we use, but you could potentially set them up either in a failover configuration for multiple connections, or load balancing, that you can spread the load over multiple internet connections simultaneously. Another thing that I need to point out is if you use the failover or the load balancing options, you can obviously set weights and other parameters as well in order to prioritize one internet connection more over another. And a use case there is, of course, if you've maybe got two different internet connections and they have different capacities, then the one that has the higher capacity should obviously have a higher weight so that it is used more than the other connection. Another example is the trusted or local interfaces, so that when you create firewall rules or traffic rules, which I'll get to in a moment, you can use that logical grouping in order to assign a rule to all trusted or local interfaces or all internet interfaces, rather than having to either create multiple rules for each physical interface or to have some rules that don't actually encompass the entire grouping or logical entity that it's supposed to. Next, you can also configure any VPN or VPN server interfaces. At the moment, we just use the Kerio VPN. You can also configure guest interfaces. So for argument's sake, if I had another Ethernet interface connected to a specific access point, I can label that one interface as a guest interface, and I can effectively create specific traffic rules for those guests so that I can, for example, restrict them from not being able to access any other servers on the network, but only being able to get basic internet access, for example. And then, of course, if there's anything that you haven't defined in any of these pre-configured groups, then they would be labeled under the other interfaces category. Next, I'm going to show you the traffic rules, and as you can see here, this is where you can apply those groups in order to greatly simplify the creation of various firewall rules. So basically what I've done is various interfaces groupings, even the trusted or local interfaces and all guest interfaces and all VPN clients are grouped as a source, and all of those interfaces are then translated out over the grouped internet interfaces. So for example's sake, if you had multiple internet connections and you were load balancing, that would still only fall under the internet interfaces grouping, and therefore the single rule will actually allow you to NAT out all of the traffic coming from the appropriate source interfaces over all available internet interfaces. So you can obviously see the same thing when you look at any of the other rules that we've got in place on our particular environment. Another thing that you can do is you can set specific NAT rules on any of these, which is why there's a couple of these rules where I'm mapping them to internal IP addresses to make those services available to the internet or to public sources. If I just expand the action quickly, you can also do things such as logging the actual packets or the connections and actually graphing how much traffic that particular rule is responsible for on your environment. Next, you can also configure various definitions. I'm basically going to skip through these options quickly and just show you the definitions because it ties back into how you would set up your traffic rules. The first of which is obviously setting things up such as IP address groups. So I've basically identified a range of servers on my local network, a range of IP ranges from various different providers all over the place, which may connect to our environment. So I'm obviously authorizing certain inbound ranges over the inbound ranges grouping, and all of those can then access particular resources on our network. Then you can do the same for URL groups. Most of these are actually pre-configured in the system. Some of them are to automatically allow things like Windows updates for machines, even if the users haven't necessarily authenticated against the proxy, which I'm going to get to at a later stage. You can also configure time ranges, and these time ranges can apply to things like traffic rules. It can also apply to things like content filters. So you can, for example, restrict certain web pages that are only allowed during lunchtime, or to only allow specific groups of people or specific users internet access at specific times, and all sorts of intricate things. Then you can also define all of your services. So obviously there's a range of predefined services available in the system, and if anything in here is not defined that you need to use in your infrastructure, you can either set up your traffic rules with the appropriate port numbers, for example, or you can come and actually add the service, note the protocol, note the port number, and such things, so that you can then create rules around that service rather than having to remember or use the port number every single time. So if I then go back to my traffic rules, for example, and this is another nice use case, I could, for example, say that guests who are then allowed to only use a grouped guest services, which include things like HTTP and email, and I can say that they are only able to access the internet at allowed times, or whatever other grouping I've defined under the time ranges section. So the traffic rules is incredibly granular and very flexible in terms of how you want to configure your rules, whether it be for grouped services, for grouped interfaces, for specific time frames, to NAT specific sources, or whatever the case may be. So it's an incredibly powerful traffic rule section. Then moving on to the intrusion prevention, obviously any UTM or next generation firewall should have some intrusion prevention facilities available. These include identifying traffic in specific severity, such as high, medium, or low, whether those are coming from things like command and control servers, or known spam servers, or compromised hosts, and other networks, so that you can basically protect your network, because any traffic originating from those sources could potentially just be dropped, as an example. Obviously, for anything labeled as high severity, it would be a good idea to log and drop, so that you can maybe investigate at a later stage. But there's a couple of options. So you can obviously log and drop, or just log it, or do nothing, depending on the severity of that particular connection coming into your network. Then obviously you can specify how often you want the signatures and blacklists to be updated automatically. So these are obviously things that are maintained by Kerio, and your system will automatically download any new definitions similar to virus definitions, of course. Then moving on to security settings, you can enable a MAC address filter. So you can obviously say that over specific interfaces, either permit specific computers from accessing the network, or depending on how many things you may need to block or allow. In my case, it's simply easier to block the single host that I needed to remove off of this local network interface. Then the system does support IPv6, but I know that typically that isn't readily available with the majority of internet service providers in Africa currently. So obviously at this point you would typically just tunnel those connections going forward. Then there's a zero configuration networking service. It basically just means that the system will automatically detect specific types of traffic and service and forward it automatically. It works very similar to the universal plug and play service. You can also configure various connection limits, either inbound or outbound connection limits, with a particular source IP or destination IP address, so you can obviously optimize your connection in that sense. You can also do things such as excluding or using a different specific set of settings when it comes to an IP address group. Because obviously it may be silly to implement a connection limit on an inbound, or sorry, not an inbound, an internal resource that isn't necessarily used by the rest of the internet or public users. Then under the miscellaneous section, you can do things like anti-spoofing, which basically validates that the source of the connection is in fact the real source and it hasn't been modified in transit. And you can also block IP addresses that are not assigned by the DHCP server. So this would prevent people from using some type of static IP reservation on a system to bypass whatever you've got configured in your UTM. Then you can set up bandwidth management or quality of service. So this is obviously available in most networking devices so that you can optimize certain types of traffic and reserve a minimum and maximum throughput so that you can ensure that that particular service works well. So a very easy use case is implementing quality of service for SIP or VoIP traffic so that you can make sure that voice calls are not affected by the rest of the traffic occurring on the network. Then, of course, you can specify content filters. Now, again, all of the items that I have in our system at the moment are all the defaults. So this will obviously block things like various botnets or command and control servers or hacking sites. You can also block peer-to-peer traffic. And for any of these, you can identify specific sources and you can apply a range of actions. So if I look at the web filter categories, at the moment it's configured to deny, it's configured to log it, and it'll also show to the users that this traffic was actually denied by a firewall policy in the event that they try to access any of these sites. Then you can obviously, as I mentioned before, you can apply specific times to specific content filters. So I could add a rule here that says things like YouTube is only allowed during specific times, so that would prevent people from abusing the internet connection at their at the work or at the office. You can configure your own forbidden words. So maybe there's specific words that you need to block out for the users. You can obviously do that here. You can also do various sets of categorization for rules. So if I use an easy example, something like CNN, and I test that URL, it obviously comes up that this is a news category. So this will allow you to see what Kerio considers various websites to be categorized under so that you can ensure that the rules that you create are configured correctly and that they aren't necessarily blocked where they shouldn't be. Alternatively, you can then see what the categorization is and potentially change that categorization depending on the circumstances. And of course, if there's specific internal resources as an easy use case that need to be whitelisted, which shouldn't be categorized, then you can obviously do that over here as well. Then, just like any modern day UTM, the system can decrypt and actually filter HTTPS traffic as well. There are in some countries certain legal requirements around that. In South Africa, for example, I know that you should always show some type of notice to your users to inform them that even when they are accessing things like their personal email over HTTPS or a secure connection, that the IT department can actually intercept that and potentially see what they are busy with. And of course, you can filter out or at least create various exceptions based on this particular filter as well. Then there's a way of identifying suspicious connections. So obviously in this case, when you're looking at high port numbers, most of the time very high port numbers can in some cases be indicative of peer-to-peer or torrent traffic that's happening on the network. So you can basically consider specific port numbers or specific ranges as suspicious connections depending on the number of connections that they are making. So obviously peer-to-peer traffic establishes many connections over many ports simultaneously, and that's why you can then identify that traffic and potentially do something with it, like blocking it or throttling it or whatever the case may be. Then the system includes a proxy server. So the proxy server is used for a couple of purposes. The first of which is logging user activity. So obviously by forcing all of the web traffic to go through an internal proxy, that proxy can then track what sites the users are accessing, and how long they are accessing them, and how much bandwidth they are using on each of those sites. And the other reason that you might want to use the proxy is so that you can cache certain requests. So obviously, if I look at things like the HTTP cache, I can basically make sure that certain items are cached depending on the normal internet activity from the users, and that just means that I use less internet bandwidth in total, because images and things that don't typically change often are then cached for all users, so that those files don't have to be downloaded again when someone else on the network goes to the same website. And as you can see here at the moment, we're sitting with well over 8,000 files in the cache. And the effectiveness of that is over 50%. So you can basically say that at least 1 in every 2 requests may be served out of cache, and it doesn't actually have to go and retrieve things off of the internet. So that's obviously a major bonus for organizations with a lot of people. Then moving on to the antivirus component. So I need to point out that this is specific to the web traffic or the FTP traffic or mail traffic. So this is, again, because this is a unified threat management appliance or a next generation firewall, the whole idea of such a product or such a solution is to ensure that certain types of traffic are basically blocked or filtered out on the perimeter of your network. So using the antivirus scanning on the UTM would prevent say viruses from ever reaching the endpoints. So even if you had a great endpoint security solution like ESET installed, it wouldn't necessarily need to do any heavy lifting. It's kind of there as yet another layer in your overall security for your network, because obviously, as everyone would know, IT security is best when you approach it in a layered approach or sense. So the more layers of security you have, the better it is in terms of your overall security. So again, the whole point of the antivirus here is to prevent things from reaching the endpoints in the first place. Then you can set up a few parameters here. So I can say what should be scanned, whether or not it should alert the users, what it should do if it does find something, should it maybe deny the transmission of the file if it can't be scanned, for example, or if it should allow it. And you can also specify rules for the email scanning specifically, such as adding special text into the subject line for the users, or allowing them to use encrypted connections on their mail clients which can't be scanned by the antivirus engine. So if you disable this, then if they use any personal or other email on their machines, they wouldn't actually be able to access it using a secure fashion. And in doing so, it means that you can then scan it because it's not encrypted. Then moving on to the DHCP server, again, any network device should have some form of a DHCP server available. At the moment, I'm specifying the range from 40 to 252 in the subnet. And the reason in our case that I did this is because the first section of that range is reserved for specific machines on our network. I can also go and edit the scope of this. I can add specific DHCP options, such as specific DNS server addresses, or excluding certain addresses, or adding anything such as particular log servers or host names, or whatever the case may be. So again, a very flexible system. Then if your environment requires it, you can also utilize IPv6 router advertisements, so that you can obviously ensure that certain advertisements are sent to other devices on the network. Then moving on to the DNS server, obviously if this system is used for internet by your users, then it would be a good idea to use the built-in DNS service as well. And in our case, what I'm doing here is I'm forwarding things for a specific Active Directory domain to a relevant domain controller. So you can basically forward requests for specific wildcard URLs, for example, to a particular DNS server. You can also obviously use the hosts table to effectively hard code or statically assign specific host names to specific IP addresses. In our case, the way that I use this is there are certain URLs or host names that are available to the public, but they are also available internally. But in our case, then what I do is I send the internal users that are on the network here. They basically go to the local IP address by an entry on the hosts file on the UTM, rather than having to do a public lookup and then basically just looping back onto the internet interface. So this will ensure that all of those DNS requests happen internally and never have to be queried externally. Then there's the routing table as well. So this is the active routing table. There's a couple of predefined routes here that get added, like when you use the WAN interfaces. Obviously, that's automatically going to add a system route, for example. The same thing for any of the network addresses assigned to specific interfaces. Those would obviously be routable as well. And then there's a few static routes that I've entered in order for specific VLANs on our network to communicate with one another and to communicate with this UTM instance and anything that sits behind it. And you can obviously do the same for IPv6 as well. Then moving on to the accounting and monitoring sections, this allows you to, as I mentioned earlier, with the grouping and with the rules, you have the ability and with the proxy to gather statistics around what your users are doing on the internet. You can obviously specify how long you'd want to keep those records. Maybe you need to exclude a specific group from these statistics, such as a CEO, for example, because they don't necessarily want you to know or see what they use the internet for, or it's simply not necessary. You can also specify basic details on how those statistics need to be handled. You can also specify a range of exceptions, so that's especially useful. Just like above, you can maybe exclude specific IP addresses like your servers that I've defined, because they don't necessarily need to be tracked. You can also make access to statistics available to the rest of the users. So I can, for example, have any of the users that are available on the system that then authenticate on the proxy of the UTM. I can allow those users to access their own statistics so that they can moderate their own internet usage, for example. And if I quickly go to this URL, so in my case now, I access this using the admin credentials, so I'll be able to see the internet traffic for everyone on the environment, which is why I can see how much traffic specific users are going through, what type of protocols those are. Obviously, the vast majority is web traffic. What type of categories for websites are being accessed, what are the most top visited websites, how much traffic is used, and when. If, for example, I then go into an individual's report, I can go into, say, my other user on the system, and I can see that the last categories was IT and information and communication, and that was over a short time frame, first at 4 a.m. and then at 10 a.m. So you can basically drill down into a specific user's activity in a bit more detail. Obviously, this can then be refined over days or weeks or months or a custom period, so that you can expand the list, and you can obviously print out those details quite easily. If I then go into the user activity, you can also see here the connections that were actually made by the user. So this is more in-depth statistics that can be used for audit purposes, as an example. Then going back to our accounting and monitoring section, I can alert around specific conditions. So maybe if someone's license is expired, or if the system's running out of space, or if there's a new version available on Kerio, so you may want to run an update, you can configure various alerting conditions so that they can get sent to specific users, for example, so that they can attend to a potential problem. Then, just like with any other networking device, you can enable SNMP monitoring. So this will be useful if you want to do network monitoring from another network monitoring system, for example. Or, of course, you can do some basic management through that as well. Then there's a remote services section. This is a fairly unique implementation, and basically what it allows you to do is in the event that you had many Kerio instances, let's say you had customer A, customer B, customer C, and you had a Kerio instance or more at each of these customers and maybe at each of their office locations. So it may be troublesome or just not necessarily very user friendly to log into every single instance using a particular URL or IP address. So what you can do is you can link all of those Kerio instances to the My Kerio service, which is a web interface that then links to all of your Kerio instances so that you can manage all of them from one URL. So that can be especially useful in larger environments or for IT administrators that have to manage many instances and they don't want to necessarily keep open various management interfaces simultaneously. Then, of course, you can relay the notifications that need to go out via email, either using the MyKerio notification service or using your own SMTP server somewhere on your network. You can also implement dynamic DNS, so you can ensure that depending on what the firewall's IP address is, that whatever hostname you've got with whatever provider is updated with the IP address whenever it is changed. And of course, you may want to take backups of your configuration so that in the event that something happens to your Kerio instance, or if you need to move to a new server, for example, that you can do that quite easily. Then under the advanced section, you can obviously specify the host name. You can specify NTP server details so that you can ensure that time is correctly synced across your environment. I have to point out that the time has to be correct and ideally the same as the time for the workstations or servers that connect through the Kerio instance, because otherwise things like the two-factor authentication, which I'll get to in a moment, will not work, because that's obviously reliant on a time code based system. So if the times don't match, then you won't be able to get the right 2FA token, for example. Then you can specify things for the web interface. Obviously, I'm using a specific host name. I'm using a specific SSL certificate so that I don't get certificate warnings here. I can rebrand the login page, so this can be great either for an MSP or for a particular organization. And then you can specify some details around updates. So at the moment, I'm just checking for updates automatically. I'm not downloading them automatically. I'm not sending any statistics, and I'm not using beta versions because that would be not the best idea in a production environment. Then, obviously, as I mentioned, with the traffic rules and with the content filters, it relies a lot on the configuration of your users, groups, and other definitions. So I've got a couple of users in here. I can go into any of these users. I can do things like saying whether or not that authentication is happening on the internal database that Kerio holds itself, or if it should use the Active Directory server for authentication instead. I can then also configure various things like what groups this user belongs to, what rights this user has, whether or not this user has a specific usage quota, such as daily limits, weekly limits, or monthly limits, and what you need to do if those limits are exceeded. Specific preferences like not filtering out or filtering out specific internet resources, and then maybe doing things like addresses. So I can ensure that in the case of my demo administrator user, that's the user that's used by our servers. So because I enforce authentication on the outbound proxy, obviously some of the servers, I'm not going to want to log into those servers every time they restart, go into the browser and then authenticate accordingly. I mean, in some cases, like with our Linux servers that are headless or don't have a graphical interface, that becomes even more difficult. So what I've done is I've basically said that if the servers are coming either from specific IP address groups or from specific MAC addresses, that they are automatically authenticated as the administrator user, so that you don't have to perform that actual authentication on those machines. Then I can obviously configure various groups. At the moment, I've just got my administrator group, or if I look at our Active Directory domain, here you can see all the groups that are available in Active Directory, of course, and then you can do the exact same thing like you do with the normal groups and actually use these to configure things like content filters and traffic rules. Then there's a few parameters to configure for domain and user login. Obviously, in my case, I'm enforcing that users are logged in before they can access web pages, which is why I've configured all of those details under the admin user, like I mentioned. I can also log users out automatically if they're inactive. I can use a specific settings in the event that I want to do radius-based Wi-Fi authentication. I can also do things like blocking certain IP addresses if they are considered as suspicious because they're trying to guess passwords. And I can also enable things like the two-factor or two-step verification. So as I mentioned before, that's why the time setting is very important, because if my workstation or laptop time does not match the server time, I will potentially get the wrong token with whatever two-step or 2FA verification app I use. Then I'm obviously integrating our system with an Active Directory environment, so that's how you would configure that. And I can configure a little welcome page that would be prompted for anyone trying to access the internet using a guest interface. And I can also ensure that if I want to protect that using some rudimentary fashion, I can apply a global password to the guests. Then, of course, I can add various SSL certificates that can be used by things like the web interface, like I've got in place, or by the VPN and a couple of other things as well. Then, if I go to the status section, I can obviously view an immediate throughput status of specific hosts on my network and which users are active on those hosts. I can see active connections, so this allows me to go through things and see in-depth information of ongoing network traffic. I can see any people that are currently on the VPN, so that I've got a colleague logged in over the VPN at the moment. I can see user statistics here as well, so I can see if people are close to their quota, if they've got one configured, and some basic metrics over daily, weekly, monthly, or total time periods. I can also view traffic charts, so if I look at a particular interface, I can obviously see a traffic graph for that over here, again over specific time frames, or in the event when I've enabled the accounting option on traffic rules, I can now see that my remote administration rule, for example, is responsible for almost a gig of traffic every month for people that are remotely accessing the web interface that I'm on at the moment. Then I can go into various alert messages, so I can see any issues that are happening on the environment. I can see system health, which is basically just resource utilization. This is also where I can reboot or shut down the instance. And then, of course, there's a few IP tools so that I can basically run some diagnostic tests from the Kerio Control instance. Then I can drill into various logs, obviously depending on what it's for, ranging from dials, which will be things like PPPoE connections as well as VPN connections, maybe any type of security rule that is being flagged, particular web requests that are being accessed by specific users on the network, and all sorts of other in-depth information. And then, of course, the last button here directs me back to this Kerio statistics section that I showed before. So, navigating back to the dashboard, there are a few things that I need to point out. The first of which is the primary competitors for Kerio Control. We basically compare with the likes of CyberRoam or FortiGate UTM, and there's a couple of others out there as well. I think another good one is WatchGuard. All of those UTMs basically provide exactly the same features. The main differentiator which sets Kerio apart from all of those providers is, first and most importantly, ease of use. As you can see with the demo that I've done now, everything in Kerio is very self-explanatory and is very easy to configure. Whereas with a CyberRoam system, for example, they can become quite complex, and you typically need to have someone that has basically been accredited or certified to actually configure those appliances, because they aren't that user-friendly. And the second point, of course, is pricing. To my knowledge, Kerio is substantially cheaper than most of those competitors that I've mentioned. So those are two great selling points for Kerio Control. Then the other thing that I need to point out is in terms of licensing, Kerio is basically licensed. The server is included with the license for the first 5 users, and then you pay for each additional set of 5 users. So it works in 5 user increments. And then you can also pay extra for things like the antivirus capability and the web content filtering. So those are not included with the normal server/user license. You need to pay extra for that. So you can either consult our price list or get in touch with your account manager or territory account manager in order to get more detailed information on pricing. So that basically wraps up our demo of Kerio Control. I hope it was informative. Please feel free to comment on this video on our wiki if you need to have any specific things covered in a bit more detail, or if you have any other questions around the product. Thank you very much.